In this video, we return to the discussion of creational design patterns, which abstract and encapsulate the details of object creation. So the next design pattern that I'd like to review very briefly is the builder design pattern. The builder design pattern is also a creational design pattern that allows the client to have a set of configurations for complex objects, basically composition of different objects that work together. And at the same time, this configuration can be changed, updated, modified. So the user, basically creation of these objects, a combination of all the objects, is quite a burden. So it's a task of its own. So these configurations could be complex, and the client wants just encapsulated, abstracted away, pretty simple way, uniformly construct complex objects for each configuration. So that's the idea, basically. Separate the client from all the possible very detailed complexities. So the director class right here has a construct operation. Okay, and let me enlarge this a little bit for better visibility. So the director has this construct operation to build complex objects based on specific configuration. So the responsibility of the director is to load the configuration and process it. So it will be generating various parts described in the configuration structure. So to create well-known distinct parts that represent individual objects that potentially present in the description of that structure that we're trying to construct, the director is using the builder interface, which has a build operation for each part that may be found in the configuration that is loaded. So a concrete builder is a class that implements creation and preparation of the individual parts. So let's take a look at the example. So here we have a maze that we'd like to construct, and of course it has a well-described configuration. So part of the configuration parts can be doors, rooms, walls, and also bombed walls, that basically the results of bombs exploded inside the room. Okay, so these are individual parts, and of course we also have the entire maze configuration. So in this sample, the maze game class represents the director object that has create maze operation. And we have two concrete builders that are deriving themselves from this common interface maze builder. So there's a standard maze builder that essentially constructs all of these things, pretty much, constructs, configures them, connects them together. But there is also a special type of maze builder that is called counting maze builder, which analyzes how many rooms and doors would be built if maze was constructed by the standard maze builder. So this is an interesting aspect to look at. There's another object that is using the same interface but gives us some statistical analysis about the configuration that we currently have. So we can start comparing configurations and maybe even figuring out the level of complexity which could correspond to the level of the game being played by the user. So there could be multiple interesting application of this counting or statistical analysis of the configuration. And so I'm going to click on this builder view right here, and in the related pages we have two sequence diagrams. one sequence diagram that shows the standard maze creation, and the second sequence diagram that displays the counting maze creation. So let's start with the standard maze creation. So this is our sequence diagram, and in this sequence diagram we just have the view of the hierarchy of objects that we have in the system. And we can, just using the sequence diagram, let's find out what are the actual steps that are represented in this sample. There are files that you can download and compile. This the prototype of this game is written in C++, so you can just collect all the classes, all the files, and build it on your own system. So again, we begin somewhere in the main function right here of our code, and we call the function that says create standard maze. So this is a demo function that is available in this program that essentially demonstrates the use of the standard maze builder. So we mentioned that the maze game object in this system plays the role of the constructor. So remember, its responsibility is to handle the configuration. In the sample of this prototype here of this maze game, it doesn't load configuration from a file. Basically, the configuration is hard-coded inside this operation create standard maze. So this is what is happening. So the first we construct the maze builder, and of course, because the maze builder is the base class for the standard maze builder, so we can see that the maze builder gets constructed first, and then the standard maze builder is constructed next. And the maze game, the director object, is constructed first. So this is the first object being constructed, and then the standard maze builder is also constructed, but its base class is constructed before the actual completion of the standard maze constructor. I just want to emphasize that this is how our classes look like in this hierarchical structure that we have in all of our class diagram right here, very abbreviated class diagram. But when we construct this object standard maze builder, basically what we have there, that of course this is the standard maze builder example right here, and we construct it right here. So this object is constructed, but before this object is constructed, its base part, the maze builder, is also constructed. Just an emphasis on this fact. So this is why in this sequence diagram, what is shown that this is constructed first, and then construction of this is completed after it. So basically, constructor of the standard maze builder invokes the constructor of the maze builder, the base class, before doing any construction of its own. It's just something that this sequence diagram shows in this specific way. So then the maze game, which is our director class right here, has a method or a function, member function of this class, a function named create maze. And apparently this create maze handles this configuration. So naturally, in order to construct everything, what it does, it goes to the standard maze builder, which we just created right here, and we call build maze. So the maze is constructed. So now this object is constructed right here, right? So this object right here is already constructed. Then we want to build the room, and so we go to the maze and we ask for the room number. So then we construct the room, and notice that the room also has the common base that's called map site. So the map site, once again, constructor is invoked because map site lives inside the room at runtime when the object is occupying its memory. So the room gets constructed. Then we tell the maze add room, and we add this room to the maze object, which is basically like a collection placeholder of all the components. And then we see that it calls get room number, talks to the room to get the room number. So the next thing that is built here, right here, part of this room, is that we call construction of the wall. And in the sequence diagram, we can see that it's done 1, 2, 3, 4 times precisely for the room. We need to construct 4 walls, and once each wall is constructed, we call set side for the room. So basically the room gets the walls, and basically there's a connection between the room and the wall. So this is indeed becomes something which is interconnected. So for instance, room has access to 4 different walls, and so the room is in control of its walls. And after this completion is done, right? So we were talking about building the room, and we gave this responsibility to the standard maze builder. The next thing that we build is the second room. So it just demonstrates that we can build multiple rooms, and this entire story repeats itself again. There's a construction of the room. After construction of the second room, we build the walls, and again there are 4 walls that being built, and then we call room set side so that the room gets reference to the 4 different walls that it contains. And then we also build the door. So there is, remember, responsibility of the actual builder is that it provides operations for constructing all parts that can be found in the configuration. So first we observed creation of the rooms, and now we're observing the creation of the door. So what happens here? We say maze, what is the room number? And apparently we're doing it for both of these rooms. And then we construct the door. So this is constructor. Obviously the name of the operation is the same as the name of the object. So this is the constructor. So we find the common wall between the 2 rooms. So we obtain the rooms, both of these rooms. We call the method inside the standard builder that computes which is the common wall, and again it sets the side, apparently passing the door as the door for the first room, and then repeats it for the second room. So now both rooms have knowledge about this door, which is just one object that connects both of these rooms. So the sequence diagram really tells us a lot about all these details and how, in those little details, little steps, really kind of complicated sequence of calls to all of these operations, we complete construction of this maze. And eventually the standard maze builder is still holding the reference to the maze. So eventually we call from our create standard maze, we call a method that says get maze. So at this point, essentially standard maze construction is complete, and we give the final product back to whoever is the caller right here. So in our case, create standard maze is just a demo within this application that demonstrates how all of this proceeds in case of a standard maze creation, so that we're using the standard maze builder. So this is why at the top of this, pretty early on, we constructed the standard maze builder.